All right, today we're going to look at something called unit circle. So what we want you to be able to do is, know what the unit circle is, identify the 16 major points on the unit circle, and that you can identify where those degrees in both radian and degree are, the angles on the circle. So what is unit circle? It is the study of trigonometry based on a circle with the equation of x squared plus y squared equals 1. And that's called the unit circle. And the reason is, if you remember back to equation of circles that you've looked at previously, circles have this form to them for the circle. Well, here, if we don't see any numbers being added or subtracted from y, that means in the unit circle we have no numbers here, that the center of the unit circle would be 0, 0. So it's always going to be centered at the origin. Also, we have this number over here, which is 1. So in our equation here, if we got that number being 1, that means r squared is equal to 1, and r is going to be 1. So the radius of the unit circle is 1. So that's what we're going to base this on when we're doing trigonometry, is this circle centered at the origin. This is 0, 0 right here. And the radius is 1. And you can see that here. This is the point 1, 0. This is point 0, 1, negative 1, 0, and 0, negative 1. So that's the unit circle. When we talk about unit circle, angles are always going to be measured counterclockwise from the positive x-axis. So this is considered right here, this line in the positive x-axis, that's considered 0 degrees. So if you wanted to measure 30 degrees, we'd move in a rotation that is counterclockwise, not the way the clock spins, but the other way. So 30 degrees, if we went this way, 30 degrees would be measured in that direction. So this angle created right here would be 30 degrees. Similar to that, if you wanted to measure, say, 150 degrees, okay, we would start with this line again as being 0, and we would keep moving here. So if we kept moving, when we hit the right angle right here, we know that's 90. So we'd have to keep moving another 60 degrees until we hit the line. Then that would make 150 degrees. So you can see here, 150 would be that angle measured from there. Also know that, remember from way back in geometry, a straight line measures 180. So this would be 180 degrees. And so you can do some easy angle math here. If we know that to this line is 150, that also tells us the angle left over there would be 30, because they got to add up to 180. And you'll have to do some of that angle math while doing some of these unit circle trig problems here. Anytime we measure in the clockwise rotation, that would then be a negative angle. So clockwise rotation is negative. So example of that, we talked about, if I move this way, that's 30 degrees. If I move that same amount in the clockwise direction, we would say that is negative 30 degrees. So this angle right here would be negative 30 degrees. Now, some other stuff related to that then. Negative 30 would also be equivalent to another angle, because we know if I traveled all the way around the circle, that's the same as 360 degrees. And so if I would stop here 30 degrees short, that would also be the same as 330 degrees. So 330 degrees would be equal to negative 30 degrees. Those are equivalent angles. They measure the same thing, just in a different direction. All right, using the degrees from special right triangles, we're going to fill in the 16 major points of this. So remember our two special right triangles that we've looked at before? That's our 30, 60, 90 triangle, and also our 45, 45. 90 triangle. So if we fill in those on here, remember we're starting with 0. The first major one we'd hit would be 30 degrees. Before we get to 60, we'd run into 45 degrees, 60 degrees. When we hit a right angle, that's going to be 90 degrees. Going from that now, we would, to get to that next major one, we'd want to advance another 30. So this would be 120 degrees. The next one would be kind of 90 plus 45 degrees. And so that would bring us to 135 degrees. And then it'd be like 90 plus 60, which would be 150 degrees. If we go in a straight line, we talked about that just a little bit ago, that's 180 degrees. Now let's add 30 to that, so that would be 120, or sorry, 110. If we add 45 to 180, we'd get 225. If we added 60 degrees to 180, we'd get 240. Now the next one, if we add 90 degrees to 180, we get 270 degrees. That's 3/4 of a turn. And now again, let's finish off here. So if we add 30 degrees to that, that'd be 300 degrees. Wrong line here. 300. If we added 45 degrees to 270, we're at 315. If we added 60 degrees to 270, that's 330. And if we just make sure and add one, add 30 degrees of that, that should bring us back to the origin, which would also mean that 0 degrees and 360 are the same thing too. So 0 and 360 on the unit circle give you the same location. So those are the major degree marks. Now, from previous lessons, we learned that 1 radian is where you take the radius and then whatever that radius amount is, if you curl it along the circumference of the circle, that angle it measures out here would be 1 radian. And then we also learned from that then that there's a little bit more than 6 of those radians around the circle, and in fact it ends up being that 2 pi radians go around a circle, so that's equal to 360 in degrees. And so if we divide by 2, pi radians equals 180, and that's our conversion that we usually use to change between degrees and radian. So now let's see if we can fill in the unit circle with our degrees, or not our degrees, our angles measured in radians. So 0 degrees would be the same as 0 radians. That's the same. 30 degrees, what's that going to be in radians? So remember what we do? Take our angle here, times by pi over 180. 30 goes into 180 6 times, so this would be the same as pi over 6. So 30 degrees is the same as pi over 6. If we did the same thing with 45 degrees, and times it by this. Now how many times does 45 go into 180? It goes in 4 times, so we get pi over 4. If 60 degrees was our starting one, how many times does 60 degrees go into 180? Well, that would be 3 times. So 60 degrees is the same as pi over 3. What about 90? 90 degrees. If we have 90 over 180, that's the same as pi over 2. Okay, and we can keep going here. So 120 now. Now the number 120 does not go into 180. But what we do know here is if we had these two numbers, 60 is a number that would go into both of these. 60 would go into here 2 times, 60 would go into here 3 times, and so this would be the same as 2 pi over 3. All right, and we're just going to keep doing that around the whole unit circle and see what we get. And you're going to hit, basically you're just going to get a bunch of fractions that have pi in there describing what this angle is. So why don't you pause the video and see if you can go around and fill in the rest of these, and then we'll check them out here. All right, check yours out and see how you did. If you did them right, you should have came up with these angles in radians for each one. Just some key ones here. Here was our conversion factor again. 180 does in fact equal pi. Also remember, because 0 and 360 are the same amount, same as 0 and 2 pi are also the same amount on the unit circle. And so those are all the equivalent angles in radians. You should be comfortable using either degrees or radians, hopefully by the time this class is complete. All right, the unit circle is divided into quadrants. So just like the coordinate plane is, the unit circle has ordered pairs like the coordinate plane does. So you do have points here like 1, 0. 0, 1, negative 1, 0, and 0, negative 1. So if we look at those points on here, what about these? So here's those points we just looked at. What are the other ordered pairs around the circle here? So what is like this point or this point? Well, in order to come up with those ones, we're going to use those special right triangles, because that's how we came up with those points in the first place. And so what we're going to use is our 30, 60, 90 triangle and our 45, 45, 90 triangle to come up with the ordered pairs there. Remember that when making these, that the radius of the circle is 1. And so if I were to draw, say, a 30, 60, 90 triangle in here, so there's my 30, there's my 90, this would then be 60. The radius is 1, and so my hypotenuse of this triangle is going to be 1. So that should allow me then to come up with the other sides of the triangle. And what I mean by that is, if this is 1, that means the short side, we know the conversion to jump between the short side and the hypotenuse in a 30-60 triangle would be to either take this short side and times by square root of 2 to go that, or sorry, times by 2 to go that way, or if I'm going the opposite way, would be to divide by 2. And so if I take 1 divided by 2, that means the length of this side is going to be 1/2. And then our conversion here is, if we want to go from the short leg to the long leg, we times by square root of 3. So if I take square root of 3 times 1/2, I'm going to get square root 3 over 2. So that would be the length of that side. In my 45, 45, 90, same thing. The hypotenuse would be 1. Our conversion to go from the short side to the hypotenuse is to times by square root of 2. And so the opposite way would be to divide by square root of 2. So this side's going to be 1 divided by square root of 2. If we rationalize that by multiplying by square root of 2 over square root of 2, this side comes out to be square root 2 over square root 4, which is 2. So you get square root 2 over 2. And remember, 45, 45, 90 is isosceles, so this side would also be square root 2 over 2. So that's the lengths if the hypotenuse is 1. So we're going to now go around and fill in the ordered pairs for this. All right, so if we go to our unit circle here, I'm going to back it up and use this one. Let's see if we can fill all these in. So we already got that at 0, we got 1, 0. The 30, 60, 90 then, if we were to draw in that triangle, we already came up with that the, sketch this in here, that if this is 1, that this length would be 1/2, and this length would be square root 3 over 2. So the x value, the amount going this way horizontally would be square root 3 over 2. The amount we'd go up vertically for our y would be 1/2. And so that would be the amount that we would fill in there. So get rid of that triangle because I'm going to want some other ones in here. So this is the same as square root 3 over 2 and 1/2. So that would be my ordered pair there. All right, what about if it's a 45, 45, 90? Okay, we just had this one up 2. We came up with that. This is going to be square root of 2 over 2, and this is going to be square root of 2 over 2. And so in this case, both the x and y axis are going to be the same amount. So if we were to fill in that ordered pair, we're going to get square root 2 over 2 and square root 2 over 2. All right, the final one here, it would be if we had a 60, 90, 30, where this is 60, this is 90, and here's our 30. Well, this is still 1. This would now be 1/2, and this would be square root 3 over 2. So here the x value is 1/2, and the y value, the amount up, becomes square root 3 over 2. So now we got all those first quadrant ordered pairs filled in. To get the remaining ones, we're going to use symmetry and what we know about ordered pairs on the axes here. So if we're going to fill in the other ones, they're just reflections. And also we want to know, like, what kind of ordered pairs do you get in each quadrant? Well, in quadrant 1, anything in this quadrant, both x and y come out positive. In quadrant 2, moving, remember, counterclockwise here, that's why this one's called quadrant 2, all our x values are going to come out negative. Our y values, though, are still above the x-axis, so they would come out positive. In quadrant 3 down here, both numbers are going to come out negative. And in quadrant 4, our x is positive, but we're below the x-axis, so our y would come out negative. So we're going to get those same ordered pairs now that we had in the first quadrant, just there's going to be some sign changes on them. So example here, right here, if I were to go straight across here, that should have this exact same y value because I'm on the same horizontal plane, so this should be positive 1/2. But my x coordinate would be the same amount, just negative, so this would be negative square root 3 over 2. Same thinking with these other ones. So we can fill in all these other ordered pairs using reflections and knowing the signs that are going to happen in each one. So this would be anything in this one going to have negative x value. So negative, negative, negative. So this would be like we just had, negative square root 3 over 2, positive 1/2. This is going to be negative square root of 2 over 2, positive y value. And this one's going to be negative 1/2, positive square root 3 over 2. In our next quadrant, some similar thinking here, like here, if I go straight down, both of these two should have the same exact x value because it goes through the same x amount right here. So I know that the x value in this one should also be negative square root 3 over 2. My y value would be the same amount, just reflected though, so this would also come out to be negative. Everything in this quadrant both come out to be negative. And so if I fill these in then, I am going to get that this is negative square root 3 over 2 and negative 1/2. This would be negative square root 2 over 2, negative square root 2 over 2. And this last one would be negative 1/2, negative square root 3 over 2. Why don't you pause the video, see if you can fill in these last ones now. All right, so if you're checking out these quadrant 4 ones, you should have gotten the values indicated here. For example, like if you went straight down from here, that should have the same x value, square root 3 over 2. Y value is going to be the same amount, just opposite sign, so negative 1/2, as you can see there. And then there's our other ones shown below. So those are the major coordinates of the unit circle that you should know. Now, in the beginning, that might be kind of hard to remember. There is one little trick you can use with your hand if you want to memorize these. So if you hold up your hand, and I kind of like to do this sideways a little bit just so it kind of mirrors the kind of the x and y axis. We're going to say your pinky here is 0 degrees. This would be like 30 degrees. Our major angles we just filled in there, 45, 60, and then this, see how this kind of forms almost like a right angle here? So this, our thumb here would be 90 degrees. Okay, if you want to figure out ordered pairs, you can use this hand trick. And how the hand trick works is you're going to cross out one of the fingers of whichever one you want to find. And then if you count the fingers to the left and right and fill in that number in the palm here of square root of however many fingers over 2, it gives you the ordered pair. Let me give you an example. Let's say we want to find what's the ordered pair here for 30 degrees. Okay, so I want to know what that one is. So what I'm going to do is put that finger down. So I'm going to cross it out to pretend I'm just putting it down. I'm going to count the fingers now to the left and to the right. So I'm going to go left first because I want the left ordered pair here. So if I count the number of fingers to the left, I can see there's 1, 2, 3. So there's 3 fingers to the left. That's the number then I would put in here. And so this would be square root of 3 over 2. The number of fingers to the right would be 1. So since there's 1 finger there to the right, that's the number I would put in here for the second ordered pair. So square root of 1 is 1. 1 over 2 then would be 1/2. And so that gives you the ordered pair. Okay, let's try another one here. So erase some of this. Let's say the next one we wanted to find here would be, let's say we wanted to find this ordered pair. Okay, so I'm going to put that finger down, and I can't do that on the board here, but I'll scribble out to pretend it's down. How many fingers to the left? There's 2, so that's going to be square root 2 over 2. How many fingers to the right? Also 2, and so this is also going to be square root 2 over 2. So it's a nice little way to do and figure out what the ordered pair is for all these. Let's try one on the edge. Like let's say I wanted to find it for 0. What's the ordered pair for 0? Well, if I put my pinky down, how many fingers are to the left? That's our left ordered pair here. Well, there you can see there's 4 fingers. So if I put 4 in here, square root of 4 is 2. 2 over 2 is 1. If I put the number of fingers to the right, there are none, so it would be 0. Square root of 0 is 0. 0 over 2 is 0, so that would be 0. And of course, that is on the unit circle, that would be the 0.10. So this is a nice little trick if you want to use it to help you figure out those ordered pairs a little bit quicker on here. So that's a nice little um, method of doing that. Here's some links if you want to watch some more videos on that little hand trick. All right, so to finish here, just so you get some practice, see if you can go in and fill in this blank unit circle on your own now, just to see how much of this you remember for the unit circle. All right.